Come on, guys. Tell me, am I audible, visible? Smash the like button. Quick, 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 quick. Smash the like button. Everybody, smash the like button. Quick. Mark your attendance. I will be sharing the notes. Okay. Chapter 10, Thermodynamics. I'll be sharing the notes, guys. Okay. So that is t.me/Yawar Manzoor. This is the Telegram channel where I'll be sharing the notes. Now, let's talk about first law of thermodynamics. Let's talk about first law of thermodynamics, boys and girls. Okay. What does first law of thermodynamics say? If heat given to the system, okay, if heat is given to the system, it can be used to increase its internal energy or to do the work done. Heat given will be used as in increase in internal energy or work done. Okay. We can write it like this: dq is equal to du plus dw. Now, boys and girls, imagine a gas is in the cylinder with the piston. This is the cylinder. There is a gas present inside the cylinder. It has got this piston. Now, if we give heat to the system, okay, if we give heat to the gas, now this gas becomes hot. The gas will basically become hot. So its internal energy will increase. Okay, so internal energy will increase. First part, if we give heat to the gas, we say it will increase its internal energy by getting hot. And the gas also expands the piston. This piston can go up. The gas can expand. This piston can go up. So, my dear NEET aspirants, and pushes the piston. So, when it pushes the piston, so means work is done. So, simply this heat given to the system is converted to the internal energy. It can store internal energy. And my dear NEET aspirants, it can do the work done also by pushing the piston. Now, this is based on the law of conservation of energy. Now, my dear NEET aspirants, if we say heat given to the system, we always say in physics, heat given to the system is positive. Heat taken from the system, we take it negative. Increase in internal energy, we take it positive. Decrease in internal energy, we take it negative. Work done by the gas, we say it is positive. Work done on the gas, we say it is negative. These are the sign conventions. Now, my dear NEET aspirants, first thing, in this particular case, let's suppose we have this question over here. A system is provided 200 calories of heat. So, heat is given over here, dq is given over here, that is 200 calories. Okay. And my dear NEET aspirants, in this particular case, if you have to convert this to the joules, you need to multiply with 4.2. So, this is 200 into 4.2. So, this would come out to be 840 joules. Okay. 840 joules. Because 1 calorie is equal to how many joules? 4.2. So what I can say in this case further, and work is done by the system on the surrounding, and work done in this particular case is given as 40 joules. Then the increase in the internal energy. Okay, then its internal energy is, we know, sir, dq will be equals to, that is dw plus, I would say, du. So dq, that is 840, and this dw, this is given as 40 plus, I would say, du. So du will come out to be 800 in this particular case. Now, my dear NEET aspirants, I need to show you something else. Okay, one more important thing, boys and girls. Okay, this I'll give you as homework. The total heat absorbed by the processes. This I'll keep you as homework. This is a simple question. This already I have shown you so many times. See, important is this one. This is important. Very, very important. Very, very important. Very important. Take a look at this. See, my dear NEET aspirants, we say these processes, isothermal process, isochoric process, isobaric process. First of all, thermodynamic processes. First of all, we need to understand isothermal process. When it comes to isothermal process, we say an isothermal process is that thermodynamic process in which temperature of the system remains constant. In which temperature of the system remains constant throughout the process. Even though heat may be absorbed or released. Even though heat may be absorbed or released. Temperature of the process will remain constant. Temperature of the system will remain constant throughout the process. Now, my dear NEET aspirants, we can say when it comes to the temperature, it remains constant. So, change in temperature in this case will be 0. Okay. So, it is slowly, example is slowly compressing or expanding of gas in a cylinder. When a gas expands slowly or compresses slowly, that is the example over here. In that case, I would say temperature remains constant. Change in temperature is 0. Now, my dear NEET aspirants, if change in temperature is 0, temperature is constant, change in internal energy will be 0. So, for an ideal gas, internal energy remains constant. So, isothermal process, that process in which temperature of the system remains constant. So, change in temperature will be 0. Change in internal energy will be 0 in that case. Okay. Okay. Now, guys, let's talk about first law of thermodynamics in isothermal process. What does first law say? Heat given to the system can be used as internal energy plus work done. If change in internal energy is 0, it will not change. So, all the heat will go into the work done. So, all the heat supplied will do the work done in this particular case. All the heat supplied will do the work done. Ideal gas equation for isothermal process. We say PV is equal to nRT, my dear NEET aspirants. This is what we call the ideal gas equation. And in this case, we say nRT are constants. Now, my dear NEET aspirants, number of moles. Okay, universal gas constant, temperature T is also constant in isothermal process. So, this and this is constant. So, we can say PV is equal to constant. If PV is equal to constant, take it over here. P is inversely proportional to V. What does that mean? That means if PV is constant, P1, V1 is equal to P2, V2. So, that means P1 divided by P2 will be V2 divided by V1. This you guys need to understand. Work done in isothermal process. Okay. So, my dear NEET aspirants, when work is done in isothermal process, this is the work done. nRT log to the base E V2 minus V2 by V1. Directly you remember this. Or you can write it like this also. nRT log to the base E P1 divided by P2. Or you can write it like this. W is equal to 2.303 nRT log to the base 10. Here is log to the base E. So, P1 by P2 in terms of volume 2.303 nRT log to the base 10 V2 divided by V1. This is work done. And when it comes to the graphs in case of isothermal process, we say temperature versus volume. Temperature must remain the constant. Pressure versus volume, it would be something like this because pressure is inversely proportional to volume. But in this particular case, temperature will remain constant at every point. If volume is increasing, it means expansion. Temperature remains constant throughout the process. Pressure versus temperature. Temperature must remain constant. So it remains the same. If you go like this, then in that case, it is increasing. Now, guys, P versus V. If the graph is like this, arrow is this, it means volume is decreasing. Volume is decreasing compression, but temperature must remain constant throughout the process. Guys, is this clear? Please tell me in the chats. Is this clear? Okay. Now you have isochoric process. Now you have isochoric process. We say isochoric process is that thermodynamic process in which volume of the system remains constant throughout the process. In which volume of the system remains constant throughout the process. So means no change in volume. So if no change in volume, my dear NEET aspirants, we say dV will come out to be 0. dV will be 0. Okay. Okay. Yes. So we say this work done will be actually P dV. What is the formula of work done? Work done here in this particular case is P delta V or P dV. When volume does not change, dV is 0. So work done in this case is 0. So first law for isochoric process. Okay. So we say delta Q is equal to delta U plus delta W. My dear NEET aspirants, if work done is 0, so delta Q is equal to delta U. So heat given to the system will be stored as the internal energy. Ideal gas equation. Ideal gas equation. My dear NEET aspirant, PV is equal to nRT. We say nR and V are constants. So we can say P is directly proportional to T. So P1 by P2 is equal to T1 by T2. Okay. This isochoric process. Now, graphs for isochoric process. Let's suppose if we make pressure versus time, P versus T. Now, my dear NEET aspirants, volume is constant, pressure versus time. We know that pressure is directly proportional to time. It will be a direct straight line. Okay. Yes. Now, boys and girls, I want you to understand one thing. What is the slope here? Slope is tan theta. Tan theta is perpendicular by base. That is P divided by T. Now tell me from the ideal gas equation, PV is equal to nRT. So we can say this P divided by T, it will be equals to nR divided by V. Now nR is constant. This is slope. Okay. So P divided by T, P divided by T. So can I say this is slope? So slope will be inversely proportional to volume. Slope is inversely proportional to volume in case of PT graph. Slope is inversely proportional to volume in case of PT graph. In case of TP graph, if it is TP graph, okay, again we say PV is equal to nRT. If I say TP graph, T divided by P graph, take it over here, it will be equals to V divided by nR. Now what is slope over here? What is slope in this particular case? You say, sir, slope is perpendicular by base. That is T divided by P. Now, instead of this T divided by P, I can write slope. So, slope is directly proportional to volume. So, my dear NEET aspirants, we say, in case of TP graph, slope is directly proportional to volume. In case of PT graph, slope is inversely proportional to volume. And temperature versus volume graph, it will be like this because volume has to remain constant. Volume versus temperature graph, it has to be like this because here volume is constant. Compare the volume V1, V2 in the given graphs. It is TP graph. First of all, you tell me, in case of TP graph, this PT graph, in case of TP graph, slope is directly proportional to volume. So the one which is having more slope will be having more volume. So we can say slope of first is greater than slope of second, because this is creating more angle, less angle, is greater than slope of third. So I can say volume V1 is greater than volume V2 is greater than volume V3, because in TP graph we say slope is directly proportional to volume. Slope is directly proportional to volume. Isobaric process, Charles' law. That thermodynamic process in which pressure remains constant. Here pressure remains constant. dP is 0. Work done in isobaric process. Now guys, we say pressure remains constant. dP is 0. Change in pressure is 0. But pressure is there. Work done is P delta V. P is P. V final minus V initial. This will be the work done. So first law for isobaric. dQ is equal to du plus dW. Okay. And then, what does it mean? Heat given to the system can be stored in the form of internal energy as well as work done. Ideal gas equation for isobaric. PV is equal to nRT. Okay. Take this P down. So we say nR divided by P. These three are constants. So volume is directly proportional to T. So V1 by V2 is equal to T1 by T2. Since now guys, this is important. Since some portion of the heat is stored as internal energy, in this case, some portion of the heat is stored as internal energy, some is used as work done. Okay. Okay. So we say, since some portion of the heat is used as internal energy and some is used to do the work done, so fraction of heat used to store internal energy. Fraction of heat used to store internal energy. Okay. How much is the portion of heat which is used to store internal energy? That is du divided by dq. That is 1 divided by gamma. Du divided by dq. That is 1 divided by what? Gamma. Okay. So this is 1 divided by gamma. And this gamma depends upon the gas. For monoatomic gas, it is different. Okay. For diatomic, triatomic, it is different. Then, my dear NEET aspirants, fraction of heat used to do the work done. If this is 1 by gamma, that will be 1 minus 1 by gamma. Okay. Or you can say gamma minus 1 divided by gamma. This is the portion of heat used to do the work done. This is the portion of heat used to store internal energy. If somebody says, what is the ratio of du divided by dw? Divide the two, it will come out to be equal to this. Du divided by dw is 1 upon 1 minus 1 upon gamma minus 1. Graphs for isobaric process. When it comes to the isobaric process, I can say pressure is constant. Pressure is constant. In this case also pressure is constant. Isobaric process. And here, volume versus temperature, my dear NEET aspirants. We can say PV is equal to nRT. nR divided by P, this is constant. So volume is directly proportional to temperature. It will be straight line. And if you say what is the slope over here, slope will be V divided by T. In this case, what is slope? Slope is V divided by T. Okay. Slope is V divided by T. And we know, sir, PV is equal to nRT. Take it over here. V divided by T will be equals to nR divided by P. nR is constant. This is slope. So I can say this slope is inversely proportional to pressure. In case of volume versus temperature graph, slope is inversely proportional to pressure. Temperature versus volume graph, slope is directly proportional to pressure. Here, slope is inversely proportional to pressure. Okay. Compare the pressure of the two graphs. This one and this is volume versus temperature graph. Volume versus temperature graph is this. This. Here, slope is inversely proportional to pressure. So we say in case of here, slope is inversely proportional to pressure. Means the one which has got more slope will be having less pressure. This has less slope, this has more slope. Okay, so I can say in this particular case, slope of 1 is greater than slope of 2. 1 has more slope as compared to 2. So I can say pressure of 1 is less than pressure of 2 because slope is inversely proportional to pressure. Okay. In this particular case, pressure is constant. And now tell me, which one is this? Recently told you pressure is constant in this case. Isobaric. Okay. This I'll keep you as homework. Please do check this from your end. Okay. Do check this from your end. This one and 2-3 questions I'll give you more. This is adiabatic process. Okay, let's finish the adiabatic process first. It will take us 1 more hour. That's it. We're done. Now, guys, take a look. Adiabatic process. Adiabatic process is a process in which no heat enters or leaves the system. Adiabatic process is that process in which no heat enters or leaves the system. The temperature changes only because of the work done, not because of the heat transfer. It is the fast transfer and irreversible also. Example is bursting of tire. So basically when tire bursts, okay, when tire bursts, the compressed air inside escapes. The air inside escapes very quickly. When the tire bursts, the air inside escapes very quickly. The process happens so fast. There is no time for the heat exchange between the air and surroundings. Okay. This is adiabatic process. First law for adiabatic process. dq is equal to dw plus du. In case of adiabatic process, heat transfer is 0. If heat transfer is 0, so take it over here. So dw plus du is equal to 0. So dw is equal to minus du. What does it mean? So work is done by the gas, because dw is minus du. Work is done by the gas on using its internal energy, so internal energy decreases. Work is done by the gas on using its internal energy, so internal energy decreases. Here you need to understand, remember this, PV raised power gamma is equal to constant. PV raised power gamma is equal to constant. Okay, gamma is what we call the adiabatic constant, adiabatic exponent. Okay, so my dear NEET aspirants, one more important thing, this is the relation between temperature versus volume. PV raised power gamma minus 1 is equal to constant. This is between pressure and volume. PV raised power gamma is equal to constant. Now see, slope of PV graph in adiabatic. Slope of PV graph in adiabatic. So slope of adiabatic, it is gamma times slope of isothermal. So slope of adiabatic is gamma times slope of isothermal. Whatever is the slope of isothermal. So slope of adiabatic is greater than slope of isothermal. If you make pressure versus volume graph, if this is for isothermal, this would be for adiabatic, because slope of this is greater than slope of this. Adiabatic has got slope minus gamma times slope of isothermal. What is the slope of isothermal? Minus P by V. So this will be minus gamma times P by V. Okay. So this gamma for monoatomic is greater than gamma for a diatomic. I told you gamma is different for different gases. It is greater than gamma for triatomic. So that means this slope of for monoatomic is greater than for diatomic, is greater than triatomic. Okay. So if I say P versus V graph, this will be for isothermal, for triatomic, for diatomic, for monoatomic. So this will be greater as compared to isothermal. We'll be making it like this. Okay. Work done in adiabatic process. This is how do we find the work done in adiabatic process. P2 V2 minus P1 V1 upon 1 minus gamma. Upon 1 minus gamma. Okay. Take a look at this question. Come on. Solve this question from your end, boys and girls. A monoatomic gas at pressure P1 and volume V1 is compressed adiabatically. Okay. So PV raised power gamma is equal to constant. Is compressed adiabatically, boys and girls. Okay. A monoatomic gas. Okay. For monoatomic gas, I can say, what is the value of gamma? Gamma is, I would say, 2 plus 1 plus 2 by F. So we can write it like this. So P1 V1 raised power gamma will be equals to P2 V2 raised power gamma. Okay, you can write it like this. Okay, because it says a monoatomic gas. A monoatomic gas at pressure P1 V1 is compressed adiabatically. Process is adiabatic. So adiabatic process taking place, a monoatomic gas pressure is changed. Okay, pressure is P1 and volume is V1, and its volume is changed to V by 8. What is the final pressure? But we are supposed to find the final pressure. Gamma is 1 plus 2 divided by F. Gamma is 1 plus 2 divided by F. F is degree of freedom. For monoatomic, it is 3. Okay, degree of freedom for different gases is different. 3 into 1 is 3 plus 2 is 5 divided by 3. So I can write over here, initial pressure is P, initial volume is V, gamma is 5 by 3. Okay, or you can write it like this. We are supposed to find P2. So P2 will come out to be P1 V1 divided by V2 raised power gamma. So P2 will be equals to P1 is P1, V1 is V. divided by V2. Finally, its volume is changed to V by 8. Raised power gamma is 5 by 3. This and this will cancel. Take this in the numerator. So P2 will be equals to P1. Then this will be 8. Raised power 5 divided by 3. So P2 will come out to be P1. We can write 2 cube. This will be 5 divided by 3. This and this will cancel. 2 raised power 5 is 32. P2 will be 32 times of P1. Okay. Now match the following. Tell me, boys and girls, in this particular case. Is this clear? Oh? Is this clear? Please tell me in the chats, everybody out there. Tell me. Now, this is a question from NEET 2017. In this particular curve, pressure is constant. And process 1 pressure is constant means isobaric. Now this one and this one, we know that adiabatic has more slope as compared to isothermal. So process 2 has to be isothermal and process 3 has to be adiabatic. And then this one, boys and girls, this one, this will be what? Isochoric, because in this case volume is constant. Volume is constant. Okay. Delta and delta W represents the increase in the internal energy and work done by the system respectively. Which of the following is true? Because in adiabatic process only delta U is equal to minus delta W. In which of the following heat is neither absorbed or nor released? Adiabatic. Graph conversion I need to show you guys. Graph conversion I need to show you. Take a look. In this particular case, this is pressure versus volume graph. We have to make its PT graph, pressure versus temperature graph. Take a look. First and the foremost thing, if we take a look at AB graph, in case of AB curve, we can say pressure is constant, P is constant. Now use PV is equal to nRT. Use this exact approach to do it. Now we say pressure is constant, N is constant, R is constant. Volume is proportional to temperature. What does that mean? If volume increases, temperature increases. Okay. So volume is proportional to temperature. If pressure increases, if volume increases, temperature increases. Now in this case, volume is increasing. So what I can say, just a second, guys. Guys, let's take a break of 5 minutes, okay? Let's take a break of, what is the time right now? 10:04. Break till, it will take us 30 more minutes. That's it. Break till 15 minutes, okay? Break till 10:20. It will take us, by 11 we'll finish. By 11 we'll finish. check. Now, guys, let's dive into the session. So, in this particular case, what I can say is that if volume increases, temperature increases. So, from here to here, volume is increasing, so temperature is increasing. So, you are supposed to make the graph in such a way, versus pressure versus temperature, P versus T, such that we say temperature must increase, okay, and pressure must remain constant. Temperature must increase because we say in this particular case AB, pressure is constant. If pressure is constant, so PV is equal to nRT. So P is constant, N is constant, R is constant. So volume is proportional to temperature. So my dear NEET aspirants, I can say when it comes to the AB, it is going to be like this. Because in this case, pressure is constant. You have to keep pressure constant and temperature must increase. So temperature must increase. This is AB. Let's talk about B and C. In BC graph, I would say volume is constant. Clearly, it looks volume is constant over here. So we can say PV is equal to nRT, use ideal gas equation. If volume is constant, N is constant, R is constant, so pressure is proportional to temperature. So if pressure increases, because in this case pressure is increasing, so temperature increases. Now, my dear NEET aspirants, pressure versus temperature. You are supposed to make this graph in such a way like this. Okay, pressure is increasing, temperature is increasing. See, pressure is increasing, temperature is increasing. This is B and C. Then if you take a look at C and D, again CD graph, we say pressure is constant. Again in the CD graph, pressure is constant. If pressure is constant, we say PV is equal to nRT. Again, pressure is constant, so we say again volume is proportional to temperature. But here in CD graph, volume is decreasing. If volume decreases, temperature decreases. Now tell me, pressure must remain constant and temperature must decrease. This is increase in temperature. This is decrease in temperature. And you see pressure is constant. This is C and this is D. Then DA. Again in DA, volume is constant. You can see volume is constant again in DA. If volume is constant in DA, boys and girls, we can say PV is equal to nRT. Volume is constant, this is constant, this is constant. Pressure is proportional to temperature. Okay. Okay. So now tell me, now if in this case, if pressure is decreasing, temperature must decrease. So that would be like this. Pressure is decreasing, temperature is decreasing. So this would be the graph. So that is shown exactly over here. This is how you guys are supposed to make this PV graph. Okay, there is this one more graph. Convert this PT graph into PV graph. Can you make it? Guys, first of all, AB. When it comes to AB, clearly I can say pressure is directly proportional to temperature. That's why straight line. I can say pressure is directly proportional to temperature. मेरी टेलीग्राम चैनल क्यों नहीं सर्च हो रही है ना? यावर मंजूर फिजिक्स नाम है उसका. Now see, pressure is directly proportional to temperature. If pressure is directly proportional to temperature, when is it possible? We say PV is equal to nRT. Guys, when can you say pressure is directly proportional to temperature? When volume is constant. This and this is already constant. So we can say volume is constant. In that particular case, pressure is constant. Now tell me how you guys are supposed to make the graph over here. Listen carefully. This is P versus V. Now, in AB, volume has to remain constant. Volume has to remain constant. I can say this must be AB. This must be AB. Because in this case, volume remains constant, AB. Then take a look B and C. This BC, pressure is constant. If pressure is constant, you say PV is equal to nRT. Now, if pressure is constant, this is constant, this is constant. So volume is proportional to temperature. Now, if you see over here, volume is decreasing. If volume decreases, temperature decreases. If volume decreases, temperature decreases. So volume is decreasing in this case. Okay. Volume is decreasing in this particular case. So if temperature decreases, it is PT graph. Sorry, PT. If temperature decreases, volume decreases. So that would be this. Okay. If pressure is constant, we say PV is equal to nRT. This is constant, this is constant, this is constant. V is proportional to T. If temperature decreases, because in this case, temperature decreases. So we say volume decreases. Done. Then we say AC, CA. In CA, temperature is constant. Now tell me, PV is equal to nRT. Now this is constant. So we say PV is equal to constant. Array, isothermal. So P is inversely proportional to V. So if P is inversely proportional to V, so graph has to be isothermal, something like this. That is given over here. I hope you would be able to solve the questions on graph conversion now onwards. Okay. Okay. This. Chapter 11. KTG. First we need to understand over here ideal gas equation. Ideal gas equation is PV is equal to nRT. This is the ideal gas equation. Okay. P is pressure, V is volume, number of moles, gas constant, T is temperature. Okay. This N we can say mass of the gas divided by molar mass. Okay. Okay. Or this N you can also say N divided by Na. N means total number of molecules divided by Na means Avogadro's number. You can write it like this also. Mass of the gas divided by molar mass. Or you can say this N divided by Na. Total number of molecules divided by Avogadro's number. Then we can say, my dear NEET aspirants, PV is equal to, instead of this N, can I write N divided by Na, N divided by Na, RT, this RT? Yes. Now, my dear NEET aspirants, we say R divided by Na, this R divided by Na, this is KB, Boltzmann's constant. So, PV is equal to N, this N. Then instead of this, we can write KB and this T. This is also the form of equation that you guys can understand, that you guys can learn. Okay. Density of the gas. Okay. So you can directly remember density of the gas will be P, we say M naught divided by RT. Directly remember this. So what is M naught? M naught is molar mass. M naught is molar mass. This was once asked directly. Density in terms of mass of one molecule of gas. Density in terms of mass of one molecule of gas. So this will be density is equal to P, this M divided by KT. This is mass of one molecule of gas. And this is density in terms of M naught, that is molar mass. M naught is molar mass. Okay. Now see, This is NEET 2016. A given sample of an ideal gas occupies a volume V at pressure P and absolute temperature T. The mass of each molecule of the gas, which of the following gives the density of the gas? Mass of each molecule of the gas is given. Mass of one molecule, that is Pm divided by Kt. Okay. NEET 2020. An ideal gas equation can be written as this P is equal to rho RT divided by M naught, where rho and M naught are respectively density of the gas, molar mass of the gas. Now, RMS velocity. RMS velocity of the gas means root mean square velocity of the gas. Now, a root mean square velocity of the gas, you can write it like this, under root of 3P divided by rho also. Root mean square velocity. How do we actually find the root mean square velocity? See guys, to find RMS velocity, first do the squaring. Whenever you have RMS means, this is squaring, this is mean. Mean means average, this is root. Apply the root. First do the squaring, then find average, then apply the root. This is how you find the RMS velocity. Like you have over here, four molecules have velocity, have speeds 1, 2, 3, and 4 respectively. First, you guys are supposed to do the squaring. Okay, that is squaring. Then you have to find the average because it is RMS, VRMS. First squaring. Okay, then average. So I can say V square average. So that is going to be this 1 square plus 2 square plus 3 square plus 4 square divided by 4. Okay. So this will come out to be squaring and then average. Find the average. Okay. So in this particular case, this would be 4 square is 16. 16 plus 9 is 25 plus 4 is 29. This is 30 by 4. Okay. Then apply the root. V average square and apply the root. This is VRMS. Under root of 30 divided by 4. It is a root 30 divided by 2. First do the squaring, then find the average, then put the root. Maximum probable speed. What is the maximum probable speed, my dear NEET aspirants? It is the speed of gas molecules. It is the speed of gas molecules at which largest number of gas molecules are moving. There is a container. Different molecules have got different speed. So the large number of molecules have got the most common speed. Large number of molecules have the unique speed. That unique speed is what we call the most probable speed. It is the most common speed among the gas molecules. Or we say speed possessed by maximum number of gas molecules. Maximum number of gas molecules have a unique speed that is called most probable speed. And this most probable speed is under root of 2RT by M. RMS is 3RT by M. And average is 8 by pi RT divided by M. And we say VRMS is greater than average is greater than maximum probable speed. Okay. Even you can find the ratio. If you find this is VRMS. X means what? X means what? X means RT by M, RT by M, RT by M. So this is root 3x, root 3 RT by M, root 8 by pi RT by M, or root 2 RT by M. X will cancel. So ratio will be root 3 is to root 8 by pi is to root 2. Okay. The molecules of a given gas has RMS velocity. The molecules of a given gas has RMS velocity 200 meter per second. There is a given gas, it has velocity RMS. V1, I would say 200 meter per second. At 27 degrees Celsius, temperature is 27 degrees Celsius plus 273. We say 27 plus 273. It will come out to be 300 Kelvin. Okay. And 10 raised power 5 Newton per meter square pressure. when the temperature and the pressure are 127 degrees Celsius, 127 plus 273, and you convert to the Kelvin, you add 273. This would become 400 Kelvin. Okay, and the pressure is this respective, the RMS velocity, it says RMS velocity. Guys, initially velocity of the gas is this is temperature. Finally temperature, this is velocity. We say velocity RMS is proportional to root temperature. See, when it comes to the RMS velocity, it is proportional to root of T. Okay, so what I can say, V1 divided by V2 will come out to be under root of T1 divided by T2. That will be under root of T1 is 300 by 400. 0, 0, 0, 0. So V1 is 200 divided by V2 is equal to root 3 divided by root 4 is 2. 2 into 2 is 400. So V2 will come out to be 400 divided by root 3. Dalton's law. What does Dalton's law actually say? Now see, Dalton's law, it states that the total pressure of the gas mixture is equal to the sum of partial pressures of individual gases. Like, if let's suppose this is gas A and this is gas B, pressure of this gas is P1, volume is V, number of moles N1. Here V, N2, P2. This is gas A, gas B. If the two gases mix, this is the mixture. What is the pressure of the mixture? Pressure of the mixture will be simply RT divided by V. Then N1 plus N2. Like pressure of the mixture is, that is, what is the value of pressure? PV is equal to nRT. PV is equal to nRT. Now tell me, what is the value of P here? That is nRT divided by V. Now tell me, what is the value of P1? Pressure mixture will be P1 plus P2. So what is the number of moles of here? N1. R is universal gas constant R. Temperature here is T divided by volume is V plus N2 RT divided by V. So pressure mixture will be, what remains, what comes out? RT by V. RT by V will come out, N1 plus N2. This is the pressure of the mixture. Okay, this is the pressure of the mixture. Now on this you have a question asked in NEET 2023. Simple question, you check it from your end, boys and girls. Okay, this I'll give you as homework. Okay, mean free path. Now see, what is mean free path? It is defined as the average distance of a gas molecule before it collides with the another molecule. Let's suppose this is a molecule. It is colliding with this molecule. Now it moves. Once it makes the next collision, the distance between the next collision and previous collision, that is the average distance. That is the mean free path. Okay, that is mean free path. And this mean free path we write average velocity into time, V into T. Or directly you write, this is the formula of mean free path. Guys, it is the average distance of the molecules before it collides, before it makes the next collision. This is the first collision. Before it makes the next collision, the distance between the two successive collisions, that is called mean free path. And its value is directly 1 upon under root of 2 pi n and then we say d square. Root 2 pi n, then we say d square. What is this d? D is the diameter of the molecule. And what is this n? N is n divided by v. That is number of molecules per unit volume. How many number of molecules are present in the unit volume? D is the diameter of the molecule. In terms of pressure, we say kT upon root 2 pi d square into P. What is L? L is mean free path. T is absolute temperature. P is pressure. D is diameter of the molecule. K is Boltzmann's constant. So basically remember this directly, this equation, it is important. And remember this equation directly, it is important. This is NEET 2020 question. The mean free path for a gas molecule with diameter d and number density n. Number density n, number of molecules per unit volume, can be expressed as. I told you to remember directly. Okay, the mean free path L for a gas molecule depends upon the diameter of the molecule as. This is the formula. L is inversely proportional to d square. B. This is the question of NEET 2020, directly asked. Then, heat engine. It will take just a minute. A heat engine is a machine that takes heat from a hot source. Heat engine is a machine that takes heat from the hot source and uses part of that heat to do the work. Okay. And throws the remaining heat to the cold place. Like. A car engine is a heat engine. Fuel burns and produces heat. When fuel burns, it produces heat. Makes the gas expand. The expansion of the gas moves the piston. So the car moves. So heat engine is simply a machine which takes the heat from the source. Some source is providing the heat to the machine. It uses that heat to do the work done, and remaining part of the heat it is sending to the cold place. That's it. That's it. Directly remember. Okay. Like my dear NEET aspirants, this is the hot source. It has high temperature. This is a cold source. It's called sink. It has low temperature. Temperature T2, temperature T1. Now, this is the input. This is the input. This is the gas over here, or this is the engine, you can say. So, when heat is given, this is the Q1 is the heat as input. Okay. This Q1 is the heat as input. Now, this gas uses this heat to do the work done. It will do the work done. This is output. This is a machine. It takes the heat to do the work. And remaining part of the heat, this is Q2. It goes into the cold place. Heat is taken from the hot source. Some portion of it is used as work done by the gas or by the engine, and some is released to the cold place. That's it. This is the concept of heat engine. And Q1, this is the Q1 input heat. This Q1 is divided into work done and remaining heat. So this Q1 is work done plus Q2. So work done will be Q1 minus Q2. You can write it like this. Now, efficiency of heat engine. It tells us how much heat is absorbed. It tells us how much heat absorbed is converted to the useful work. If I say you are sending, let's suppose, 100 joules. Only 20 joules is used as work done. Rest will go into the sink. So means its efficiency is less. How much amount of heat absorbed is used as work done? That is efficiency. If large amount of heat is used as work done, so efficiency is large. And we say this neta means efficiency. It means output divided by input. Output is work done. Input is Q1. So this work done, you can write it like this also, boys and girls. Q1 minus Q2. This work done, you can write Q1 minus Q2. This is Q1 over here. So you can write 1 minus Q2 by Q1 also, something like this. Okay. Now there is a theorem that is what we call Carnot's theorem. You directly remember T1 divided by T2 is Q1 by Q2. Okay. T1 divided by T2 is Q1 divided by Q2. If you do the reciprocal, so that is T2 by T1 is equal to Q2 by Q1. So can I write, instead of this Q2 by Q1, I can write T2 by T1. So 1 minus T2 by T1. T1 is the temperature of the source. T2 is the temperature of the sink. You can write it like. So directly remember this formula. This is the efficiency in terms of temperature of the source and sink. This in terms of Q2 and Q1. Q2 is the heat which will go into the sink. Q1 is the input heat. You can write it like this, or work done in terms of work done and Q1 also. I have told you all the formulas of efficiency. Okay. And also, when it comes to the Carnot's engine, it is an imaginary perfect engine that converts heat into work in its best possible way. It is an imaginary concept. It's an imaginary perfect engine that converts heat into work in its best possible way. It is an ideal engine with maximum efficiency. Means there is no heat loss. Means all the energy, all the heat is converted to the work done. That's what we call the ideal engine. No heat loss. No heat goes into the sink. We say no real engines can be more efficient than Carnot's engine. No real engine. We say heat loss will be there. No real engines will be efficient than Carnot's engine. Now, my dear NEET aspirants, I have put up 2 questions over here on the Carnot's engine. Answer I have mentioned. Please do check this from your end and solve this from your end. This one and this one. Please do check these 2 questions from your end. Okay. And this one. Okay. Yes. Now, I think here we need to end it because we have 2 chapters remaining that I'll cover in the next session. But right now, I'm extremely tired. I know you guys are too. So that's all for today. Thank you so much. Do let me know in the comments of that stream also. Comments of that stream, how was the session? Still we completed 11 chapters, huh? Okay. That's all for today. Thank you so much, ladies and gentlemen. It was nice talking to you. Smash the like button if you're not like this session yet. Come on. Do let me know in the comments, huh? Do let me know in the comments of that stream as well as this stream. Take care and bye-bye. Thank you so much. Love you all.